Welcome to Chapter 7, everyone. Today we're going to start off with Lesson 7.1.2. Now, last chapter we were all about geometry, transformations. That was slide, flip, turn, and dilations. That's what all of Chapter 6 was. All Chapter 6 was trying to do was to let everything that we learned August to December, we needed time for it to sink in. We're going to go back to a lot of those notions in Chapter 7, looking at relationships, looking at graphs, looking at lines, okay? And so we're going to go back to much of what we have already learned. So today's question, is there a relationship? We're going to organize information in the scatter plot. And question, can I use this data to make a prediction? This is the purpose of 8th grade mathematics, is to learn to make a prediction. Predictions like weather, predictions like gas prices, economy, predictions like, are you going to graduate from the 8th grade? Those are predictions that we have to make as mathematicians for the future. So you should have a new math notebook, Chapter 7. The first page I want you to notice is Lesson 7.1.2. And we are going to be starting with 7-13. How much is that car? Nate and Rick were discussing cars again. Nate claimed that cars with lower odometer readings were more expensive than cars with higher odometer readings. Okay? Odometer is number of miles. Okay? His evidence was that his car with 23,000 miles was worth more than Rick's car with 31,000 miles. To investigate Nate's claim, the boys collected data from several car advertisements and found the information in the table at right. Okay? So here's our question looking at this data. Okay, we're not on problem 7.14 yet, so I can kind of set that down to a side. But I want you to look at this information. Okay, you'll notice in your notebook you have like 4 lines. And the question is, does the information in this table support Nate's claim that lower odometer readings cost more money? That is the claim. Do you believe Nate's claim is correct, that cars with low odometer readings cost money? Write a sentence. Pause the video and write a sentence. Okay, so if we look at the data, let's go ahead and highlight a situation where lower odometer readings cost more money. Here's a low odometer reading costing a lot of money. However, there are some anomalies. Okay, notice, here's a 28 with less money, higher, more money. So there are some inconsistencies there, but hopefully you have a sentence written. Next question. Melissa looked at the data from problem 7.13 and said, I need to be able to see this data as a picture. I cannot tell if there's a relationship from the list of numbers. She decided to use a box plot. Remember, a box plot shows the spread of information. How dense is the information? Her box plots for odometer readings and price readings are shown. Do these pictures help you decide if Nate is correct? Remember, Nate is saying that low odometers, new cars, cost more money. Do these pictures help you? Do you even read box plots? The answer is no. This doesn't help me. Okay? And it shouldn't help you. And it shouldn't help you. Okay? Odometer reading as a box plot, price reading as a box plot, all it's telling you is how spread out the information is. For example, if you look right here, this is really spread out information. This is information really close together. This is information really close together. This is information really spread out. Does that help us make a decision? No. So in your notebook, off to the side of your box plot, I want you to write this sentence. These box plots do not help us see a relationship in the information, period. these box plots do not help us see the relationship. There are all sorts of announcements today. These box plots do not help us see the relationship between these box plots do not help us see the relationship in the information, something along those lines. Okay? You don't use box plots for relationships. So that brings us to the meat of today. Today's primary problem. Problem 7-15. Melissa wondered if a coordinate grid would help us determine if there's a relationship. Absolutely. This is definitely where we want to work. Okay? So here's what we are going to do today. We are going to be working with this information. You can see it in your textbook. And what you need to do is you need to scale your graph like mine. You need to label it miles, label it price. And then you're going to go through and you are going to plot the coordinates. You're just going to be diligent and you're going to plot these coordinates. So for example, my first coordinate, 35, 38. So I go to 35. I don't put a dot there. I'm showing you. 0, 35, and then I go up to 38-ish, would somewhere be in there. Okay, and then my next one, 55, 16. I go 55, there's 15, so 16 is like right there. Okay, you're going to go through and you are going to plot this information. Pause the video, plot all the points now. Now, I want you to notice, I'm going to go ahead and go through several of these questions. You have lines underneath the scatter plot to record these answers. And what I want you to do is look at your scatter plot. I only have a couple points, but I have some very important points that I wrote down. Okay. Question letter B. Describe the scatter plot we just created. Okay. In general, do these dots go uphill or downhill? Well, I notice that I can kind of take a line, and if I connect the highest dot with the lowest dots, I notice that in general, I have a relationship that is decreasing. I want you to write on your line, problem letter B. I notice a decreasing relationship. I notice a decreasing relationship. Okay, we want to pay attention to how they are clustered. Are they really spread out? Are they pretty consistent? Those are all things that we want to pay attention to, that we're going to develop this chapter. Question letter C. Place an additional point on your graph for Nate's car that has an odometer reading of 23,000 miles. Explain your strategy for deciding where you put the point. Well, I want you to notice that I put a line because this is describing the general information. Now, we're going to work towards this notion of developing a line of best fit, okay? But I'm going to start by putting this line on here. Notice I connected the dots 6 and 50, and then I took both of these and I kind of put it out there in the middle, okay? And I just created a general line. I don't know that this is the best line, but it's a line. And this is going to help me with letter C. If I'm looking at the point with 23,000 miles, how much would it cost? Well, here's miles 23, and I'm going to go up to my line. Because if I put my point right there, that doesn't fit my data. If I went 23 up here, a 23,000 mile car shouldn't cost that much money. That doesn't fit my data. According to our graph, if your car has 23,000 miles, it should be somewhere close to the line. So please place a dot in your data that matches it. If you have different colors, you can use different colors. If you don't have different colors, put a dot and circle it to help us know that that is what it is. Now, for problem letter D, I would like you to put a line of best fit on there. Grab a ruler, draw a line through your information so that, you know, you kind of have dots above and below, right? You want it to go through the middle of your data. You wouldn't want your line of best fit to be above your data or below your data. You want it to go through your information. Okay? Let me erase a whole bunch of those points. I want those off my screen. Now, problem letter E. Using your line of best fit, can you predict the price of a car with an odometer reading of 80,000 miles? Well, I'm going to go to 80,000 miles. I'm going to go up. How much money is an 80,000 mile car worth? Down below on your lines, problem letter E. An 80,000 mile vehicle should cost about that much money. Problem letter F. Based on this scatter plot, would you agree with Nate's claim that cars with a higher odometer reading costs less money? What do you think? Is that true? Is that true if you went to the car lot, Ford, Chevy, Dodge, Honda, Toyota, any of them, and you bought a brand new car, 0 miles? That's going to cost the most money possible. You find that exact same car, let's say it's a Toyota Tacoma. Brand new Toyota Tacoma, 0 miles, versus a Toyota Tacoma, 100,000 miles. Well, the 100,000 mile is going to cost less. You find a Toyota Tacoma with 200,000 miles. It's going to cost even less. You find a Toyota Tacoma with 300,000 miles. It's going to cost even less than that. Now, yes, there are always exceptions, right? Because if you're comparing a different vehicle, different brand, then you're going to get different patterns, okay? The more luxury you get, the higher price you get. The bigger vehicle you get, the more it's going to cost, okay? The bigger engine, right? All these things can play with it. The purpose that we need to write here in letter F, on the line below, letter F, yes, we agree with Nate's claim, period. Low mile vehicles cost more than high mile vehicles. Yes, we agree with Nate's claim, period. Low mile vehicles cost more than low mile vehicles. Okay? Perfect example. I wanted a truck. I can't afford a new truck for $60,000. I don't have 60 grand laying around. I decided to buy a truck with 300,000 miles for $11,000. High miles, but it's a truck. I drive a Ford Excursion with, now it has 330,000 miles on it. Yes, I know, it's old. The paint is chipping. But it carries all my kits, carries all my stuff, and it's a good vehicle. But low mile vehicles do cost less. All right, let's go ahead and hop into our final problem. You have 4 scatter plots. You can see that fourth one is hiding. How fast, so you have 4 choices. This is kind of a mix and match problem, okay? You have 4 scatter plots, and you are trying to decide, in general, here is a positive relationship, a negative relationship. This one, there's no relationship. And this one right here has no effect, okay? That means that one thing is increasing, but the other doesn't really fluctuate. What you need to do is figure out which of these, A, B, C, and D, which of those matches with those. I almost made it without another interruption. You guys need to finish with which of these match. I do want you to please write the sentence next to the graph. That way we can look at the graph and try and make the assumption that it's right or wrong. Make sure you record A, B, C, and D, the sentence, next to each appropriate graph. Thanks for coming today as we discover more about relationships on scatter plots. We'll see you next time.